Thanks for coming to the session. My name is Nicolas Foss. I'm an epidemiologist with Iowa Health and Human Services. I work in the Bureau of Emergency Medical and Trauma Services. We verify 120 trauma centers in the state of Iowa, and we also verify all of the ambulance services in the state. And so most of my work has to do with sort of assessment of quality of the services that are provided. And I'll just put this slide up. I won't read off it the whole time. But you know, within the trauma space, the American College of Surgeons has identified a number of different quality measures that every trauma center should be actively monitoring and calculating. Problematically, most trauma centers, unless they're a level 1 center that's like an academic center or a level 2 center, probably don't have analysts or researchers working for them. And so many of these facilities, especially rural trauma centers, don't have a lot of resources to sort of do good calculations of their quality and their performance. They're struggling just to make sure that they're getting all the information into the trauma registry that they are required to by law. And the same probably even more can be said for the ambulance services. And I don't think this is an Iowa problem. This is probably across the board a professionalism issue and a system development issue in the EMS world. Most emergency medical services don't have people that can do analyses of the data that they're submitting to a registry to gauge sort of what the quality of their services actually is. Kind of like the American College of Surgeons has published measures that trauma centers should be using to calculate their quality. There is an organization, a nonprofit, called the National EMS Quality Alliance, and they recently were started up in 2019 and published 21 measures of quality that can be calculated using national data or registry data. And so, you know, the good thing about working with trauma data and EMS data is there are stipulated formats that hospitals and EMS services have to use to submit their data to registry. So you get data in similar formats, no matter which EMS service you're working with. The problem is the data collection is not always a high priority on the list for EMS services, and same could be said for the trauma centers, especially smaller rural centers that are struggling just to get information into the registry. And so what I did over the past year is develop 2 packages to work with trauma data. One's called traumar, and then one is called NEMSQA. And NEMSQA is designed to work with emergency medical data. And so we have, I think I talked a little bit about this, but we have some national sort of standards for trauma registry data. We have national standards for emergency medical service data, and so that's a plus. However, there are pitfalls when you're working with these registries that can be very challenging. And some of you researchers that have worked with some of these data, you understand exactly what I mean. Just a few acronyms. One of the acronyms you might see, sorry about I should have changed my power settings. In fact, that might be something I can't change. So one of the downsides of working for government is they make your computer do all the things that they want it to do. So IT tells me and my machine what we're allowed to do sometimes. So I might not be able to do anything about that, and I'm sorry. I'll try to keep the screen on. But just a few acronyms. One of those is NEMSQA, and the other one is CQIC. In Iowa, we have an organization, or it's a committee comprised of stakeholders around the state, mostly trauma surgeons, mostly trauma nurses, trauma program managers, people working in hospitals that work with injured patients. And so the CQIC is a group that has published so far 13 indicators of quality in our trauma system. And so the traumar package actually implements those measures using trauma registry data. A few of the other things that I did with traumar is provide methods to calculate risk-adjusted mortality metrics, which is an important concept when you're providing care to injured patients. You would like to know, based on a risk-adjusted calculation, you'd like to know how well your trauma system or your trauma centers are doing with their patients. And it needs to be a bit better than just looking at the number of patients that live divided by the total number of patients, or the total that died divided by the total number of patients. You would like to understand, maybe based on age, based on the mechanism of injury, and other components of the person's injury experience. And so in traumar, I'm not going to talk about the WM and Z scores. Those are really, those measures come from the Major Trauma Outcome Study from the 1990s. And they're really good, robust metrics. They're still risk adjusted. But what I'll show today for traumar is related to the indicator functions that I use that help you calculate sort of how well your trauma center is doing related to different measures of quality. And then I'm going to show you a little bit about the relative mortality metric that was created by Napoli and colleagues, but it gained absolutely no traction, which is an absolute tragedy of publishing in academia, and then kind of the research kind of drops off. But they calculated they created an algorithm and then also a formula for calculating risk-adjusted mortality that I think does a lot better than what the major trauma outcome study did in the 90s. And so I implement that. I worked with Dr. Napoli. He's currently like at NASA or something like that, doing amazing things there. But he gave me his code in MATLAB, and I translated it all into R to be able to calculate the risk-adjusted, or excuse me, the relative mortality metric. So I made up some data. If you go to the GitHub repo related to, so it's BEMTS-HHS. At GitHub is the tag for my repo, and then if you go into the useR 2025 repo, you'll be able to see how I created all this code. I'm not going to show you here, or how I create all these data. So these are not real trauma registry data, but they are very similar in the way the different variables are distributed, et cetera. So we have a few variables that we're looking at. So the activation level, which is a trauma team activation in a trauma center. When they call a trauma team activation, the whole trauma team will come into the trauma bay and will begin to address the patient. And if a trauma team activation is not called, fewer resources are given to the patient until possibly later on in their care. And so whether or not a trauma team activation is called is very important, a very important measure of quality. Also, the provider type, so are they a surgeon? Was the provider type an emergency medicine doc? Was it an RNP? The level of the trauma center, with a level 1 center being the most resources, an academic center. They have 24-hour surgeon coverage. They have 24-hour ortho. They have everything you would need for an injured patient, down to level 4, which is typically a rural trauma center, no surgeon. They might get them borrowed from another center if possible, but typically they're just going to transfer the patient to definitive care. And then you have response time in minutes of the provider. You have the name of the provider, the probability of survival, and then you have whether or not the patient survived. I just created some arbitrary groups, and then indicators telling us whether or not the patient died. Okay, so we want to answer the question, in what proportion of trauma cases was the trauma surgeon present in the ED within 15 minutes, which is an important indicator for level 1 centers, and then also within 5 minutes of patient arrival in the ED. And so we have the SEQUIC indicator 1 function does this calculation for you. And so you just have to pass the different variables that are involved in the calculation. So, I mean, I think they're fairly intuitive. You just need the trauma team activation level. So was it a level 1 activation, meaning the highest level of activation, the most resources possible to be given to the patient? Sorry about that. What was the provider service type? What level was the trauma center? And then it's like a unique identifier for the record, which is very common in trauma registry and the EMS registry. And then the response time in minutes, so we can begin to calculate sort of how well did they do. And so then what's returned is it's always a tibble, and in this case, we can see that the level 1 and 2 centers did very well as expected. You can optionally pass to the calculate CI function. If it's null, it won't calculate the confidence intervals, but you can get Wilson or Klopper-Pearson intervals if you want. So if you're working with a sample instead of your population level data, you can do that. Okay, and so this is just 2 of the indicators. By default, out of the box, the function will give you the numerator and denominator, so the total number of cases that met standard, and then out of the total N of records for that, in this case, hospital level. But here I just took those out because I kicked them out for interest in space. Okay. So that's the sort of all of the SEQUIC functions or all the indicator functions work in the same way. You can calculate hospital quality based on other measures, such as the mortality rate in your hospital to see sort of how many patients are dying. But then it's also stratified by risk. So the patient's risk related to probability of survival, if they were more expected to die than not, and you can stratify it in other ways as well. The other cool thing the indicator functions will do is they'll accept a .by argument. And so if you want to do other sort of custom groupings, you can do that, and it just basically passes the .by argument to summarize, to the dplyr or summarize function. Related to risk-adjusted mortality, if most trauma registries will already calculate the probability of survival for you, and really the probability of survival variable is a predicted probability from the logistic regression model that they completed in the major trauma outcome study. So you're just basically using the coefficients from that model, and then you're calculating predictions based on the patient data. So it's just a predicted probability. And so if you don't have that in your registry data, this probability of survival function will calculate the prediction for you. And so you can have that probability. So one of the challenges that we've had in looking at trauma cases is people oftentimes lump patients into groupings that aren't so helpful. And so oftentimes people don't look at actually the performance that a facility has compared to what we would have expected based on this model. And so you typically just look at like how many patients lived and died in age groups or within sort of other demographic groups. But what about what would we have expected based on the patient's calculated probability of survival? How well did that facility do, or how well did that trauma system do with their patients compared to what we would have expected? And so Napoli did a much better job than what Champion and colleagues did in the 90s. What you have in the major trauma outcome study is sort of a linear binning algorithm. You just look at patients based on the 0 to 10% survival rate, or probability of survival, 10 to 20%, and so on. Nick Napoli developed a nonlinear binning algorithm that's meant to be used to work with the predicted probability of survival to divide up your patients into bins or into groups. And one of the things to think about is probability of survival in patients that present to trauma centers is heavily negatively skewed. And so most of your patients are 80+% likely to survive that come in. Contrary to what you see on television, on your Netflix shows that you enjoy watching, most trauma patients that come in are people that have fallen. 60 to 70% of injuries are falls. They're not majority of motor vehicle crashes or people that require major blood transfusions and all the bloody stuff that you see on television. And so majority of your patients are actually pretty likely to survive when they come into the trauma center. They're getting shipped in by EMS because of trauma triage protocols. And so by default, some of the measures of risk-adjusted mortality are showing you how well you perform, really based on how well you perform with your patients that were already likely to survive. And so you need to look at your patients in a more granular way in order to understand whether or not you're actually performing well, and also to identify pockets of patients where you're really not doing very well, and you might want to know why is that. And there can be all kinds of reasons. One of the major biases that trauma centers have is elderly falls. And so they won't be triaged as carefully because, well, elderly people, they live longer, they start falling more, and they fall multiple times, and you've seen them before, and so you're not going to call that trauma alert, and that might not get you to the head CT as fast, and so that patient may die when they could have lived. It could have been a preventable mortality or a preventable death. And so the relative mortality bin summary is a function that will utilize. Under the hood, it uses another function in the package called nonlinear bins. It will bin the patients for you based on the probability of survival, and then it will calculate the relative mortality metric, and then it gives you all of the components of the formula so that you can kind of do a sanity check. And so the divisor and threshold really just kind of help create the bin widths, and then they also specify, because we know that probability of survival is negatively skewed, it will define the area within that empirical distribution where you want the bins to be more granular or wider. And so this is the kind of output you get. You get the total alive and dead, and you also get the total number of patients within each bin. You get the estimated or observed mortality in your group, and then you also get the anticipated survival and anticipated mortality for your patients, and then you also get bin widths and the relative mortality metric. The relative mortality metric is on a scale from -1 to 1, with negative scores being your trauma center or your trauma system was more associated with losing patients in that group, and positive scores meaning that you actually performed above the national benchmark and what we would have expected for that patient group. And so in this kind of a view, you can begin to examine your patients a little more carefully and see how your trauma center is performing. And the other columns that you can't see here have to do with the confidence intervals, which are also optional, and then you get bootstrap, relative mortality metric and bootstrap confidence intervals if you want. Okay, so how am I doing with time? Like 5 minutes? Okay, I spent a lot of time on the trauma data. The EMS data is very similar, although there are a lot of problems with missingness in EMS data, and that's one of the things that I want to develop into the NEMSQA package, is to be able to assess sort of when we're calculating measures of quality for the EMS services, how much missing data did we have to deal with. And that's not currently a feature, but it's an issue in the repo right now. So this is just some fake data. These are some patient dates of birth, incident dates, patient age and age units. E-response 05 is an indicator of, was it a 911 call? Was it a mutual aid call? E-medications is self-explanatory. E-procedures were the procedures that were conducted with the patient. And then E-vitals is pulse oximetry or oxygen saturation. And then I just made up a county, which is just A, B, C, D, E, F, G. So there are two functions in the package. One of them actually gathers the population of interest using the technical specifications from NEMSQA. So it will gather up the records based on the filters that you have to apply. If you go to NEMSQA's website, you can create a free account and you can check all the technical specifications. They have a ton of pseudocode in there that you can review and see exactly how the populations are identified. So you're typically not just looking at like all 911 calls or all transports. You're typically looking at a very specific group of patients for each of the measures. And then there are wrapper functions like respiratory O2, which is the respiratory O2 measure in NEMSQA. And the wrapper functions will calculate the percent performance. And so you would use the trauma data in this way. You can also group your calculations using dplyr summarize .by argument. It'll just pass the argument directly to that. You just have to pass it strings. I didn't do that in this case. But this, currently we're using a population function, and that will get us some counts of the patients for each of the filters that we use to get down to the patient population we're actually interested in. And so the population function, in this case, it gives us 5 different objects. It gives us the initial population, which is the population before you split in age groups. Typically, all the measures will look at adults and peds for the different measures. And so you can kind of do a sanity check of your data to make sure that it's getting you the population you needed. So you'll always be able to check how the software is actually classifying your patients. And so if we look at the first element in the list that gets returned, we can see out of the 500 patient records, there were 97 where oxygen was given as a medication. Oxygen therapy is a procedure in 106 cases, and so on and so forth. Pulse oximetry less than 90%, how many 911 calls we had, and we can get the denominator for the populations we're working with, and including the total initial population that is the final data set that we're going to work with to do the calculations. One of the things I don't like about this package is there's a lot of arguments to the functions, and I want to change that with being able to have the package just kind of identify the columns, because the columns all have conventional names based on the National EMS information system. So every registry has the same column names, basically. So we could easily implement like regular expressions to find those for you. And that's also an issue already in the repo. But this is just kind of what it looks like right now. And you can get optional 95% confidence intervals if you'd like for the binomial proportions. And so this is what the output for respiratory O2 would look like. So we can see by county for the adults, peds, and the total population for that county that was examined. We can see the performance on this measure. So what percent of our patients received oxygen that were hypoxic. And we can see that some of these counties really need to ramp it up and do some training on taking care of their hypoxic patients. So currently, this is being used The traumar package is being used in Iowa. I just released it this year. NEMSQA is getting used by a few other states that have offices like, or the same bureaus like my bureau. And so they're currently using that, and they seem to have few complaints, although maybe they're being really nice to me. These aren't like anonymous, these are like people that I see at conferences quite a bit, so hopefully they're not being too nice and they're identifying the stuff we need to work on. But yeah, we built these to be fast and to be intuitive, to create outputs that are intuitive for folks, especially for people that are working in, like in actual boots on the ground practitioners. We wanted to make sure that they could begin to use these and encourage more use of data analytics to inform practice, which is an issue in the trauma field and is an issue in the EMS field by far. And so, yeah, there's just a few of us that are contributing to NEMSQA. I'm the only one working on traumar right now. And I would welcome any of you guys, if you guys are interested in this field and working in injury epidemiology or EMS epidemiology. If you want to get your feet wet in this with us, come on over and hang out, and I'll take some questions.